Hello everyone, I'm Pubali Das Sarkar. Today, we'll explore the bisection method. The bisection method is a numerical technique for finding the root, 0, of a real-valued function. In plain terms, it's a way to solve equations like f(x) is equal to 0 when you can't solve them analytically. It's a root-finding technique for continuous functions, times the bisection method is a root-finding technique times it applies to continuous functions times based on the intermediate value theorem times simple, reliable, but relatively slow. The principle relies on repeatedly halving intervals times if f(a) and f(b) have opposite signs, there exists at least one root between a and b times the interval is repeatedly halved times the midpoint is chosen as the new approximation times the process continues until the desired accuracy is achieved. These are the algorithm steps. Note the sign change. Choose two points a and b. Make sure f(a), f(b), 0. This confirms the root lies between a and b. Compute the midpoint CC is equal to a plus b to evaluate f, c. Check if f, c is 0 or close enough. Update the interval if f, a, f, c, 0 set b is equal to c. Else, set a is equal to c. Repeat until f, c is less than your chosen tolerance level. This flowchart visually represents the process. Let's look at an example. These are the advantages. Simple and easy to implement. Always converges if f, a, f, b, 0 f, a, stable and reliable. Disadvantages: slow, linear convergence. Needs the function to change signs in the interval. Not efficient for multiple roots or flat regions. The bisection method is a numerical technique used to find the root, or 0, of a continuous function. It works by repeatedly dividing an interval in half and selecting the subinterval where the function changes sign, which indicates the presence of a root within that subinterval. This method is particularly useful in situations where other methods, such as Newton's method, may not be applicable due to the function's complexity or lack of a suitable derivative. Here are some key applications of the bisection method, like root finding for non-differentiable functions, solving equations in physics and engineering, numerical integration optimization problems, finding eigenvalues in numerical linear algebra, simulation and computational science, computer graphics, ray tracing and intersection problems, control systems, etc. Thank you for your attention.